Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking, write a VHDL description for the 4-bit binary counter in figure A using a register for the D flip-flops and Boolean equation for the logic. Compile and simulate your description to demonstrate correctness. Okay. Now first I'm going to write the explanation for this. Explanation. We are to create a program that simulates a counter with 4D flip-flops, with 4D flip-flops and count enable en with outputs Q0 to Q3 for serial gating. Now let's write the program plan. We will define our 4 flip-flops, large gates and input and outputs. We will define our 4 flip-flops, logic gates, and inputs and outputs. We will wire each gate and flip-flop up according to the diagram in this diagram. So let's write that one. We will wire each gate and flip-flop up according to the diagram, this diagram. Now let's go ahead and write the program. So first here the VHDL program look like this. Library IEEE use IEEE std logic -1164.all and semicolon, and after that we include our initial standard library for digital circuits. We include our initial standard libraries for digital logic circuits. Now let's write something else. Okay, digital logic circuit. Now entity register 4-bit is we will declare our different parts as either input or output. Okay, so first entity, let's separate this one. Entity register 4-bit is we will declare our different parts as either input or output. Let's put the part C, clear clock colon in std underscore logic semicolon, and D in std underscore logic underscore vector C out colon out std logic underscore vector and Q colon out std logic underscore vector 3 down to 0 and bracket close semicolon end register 4-bit. The next thing is we define the architecture of the circuit by declaring our different components and our wires. So let's write that one right here. I erase this part. We define the architecture of the circuit by declaring our different components and our wires architecture register 4-bit architecture of register underscore 4-bit is we declare our XOR gate with input and output component XOR 2 part C in 1 comma into colon in std logic out 1 out underscore std underscore logic semicolon bracket close semicolon. This is bracket, okay, bracket close semicolon, and end component begin, and we wire up our two gates with inputs and outputs we created earlier. So let's write that one, note that one down right here. We wire up our two gates with the inputs and outputs we created earlier. And let's go and write that one. Since I need the space, I am going to erase this one. I hope you guys already know these things. Let me erase this part and continue it right here. Let's continue the code. Before that, I separate this. I put a line so there won't be any problems. Okay, now let's continue the code right here. Here I start with geo XOR 2 port map en q0 q of 0 and d0. G1 XOR 2 port map and out 0 Q1 D1. And G2 XOR 2 port map and out 1 Q2 D2. Now the next thing is G3 XOR 3 XOR 2 port map D3 XOR 2 port map and underscore out 2 Q3 Q of 3 D3. And then G4 and 2 port map and this G4 not and this en Q0 and underscore out 0. G5 and 2 port map and out 0 Q1 and dash out 1. Then G6 and 2 port map and out 1 Q2 and underscore out 2. Next thing is G7 and 2 port map, port map, and underscore out to Q3 C out, and signal and underscore out, std underscore logic underscore vector 0 to 2. Okay, let's continue this side. Let's get rid of all these things. Zero to 2, and process clock clear begin, and here we define the functions of our D flip-flops with the reset and rising edges. So let's write that one. We define the functions of our D flip-flops with reset and rising edges. Rising with rising edges. Okay, let's continue here. If if clear is equal to 0, Q is less than or equal to 0, 0, 0, 0. Else if clock event and LK is equal to 1, then Q is less than or equal to D, and if end process, and finally end if end process, and let's get rid of this thing. End process, end reg underscore 4 underscore bit underscore arc and a semicolon, and that's it. That's our final thing. I know it's a long code, but that's how it works. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn digital logic design, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.